So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the GCSE Maths higher topic of exponentials. We'll be looking at what is an exponential, what is a exponential equation or a function, and looking at the graphs of an exponential before going through some past exam questions. Now, an exponent function is one where the variable is a power or an exponent. Now, for example, any function in the form of f of x equals a to the power of x, where a is a constant, is classed as an exponential function. In other words, an exponential is when the variable or the letter is a power. So, for example, in previous equations, so if we just had y equals x plus 3, then x is just going to be a whole number. And when we've got this big number, then we call this the base. So if I had a to the power of x, then a is the base number and x is the power, or the index or the indice as the plural term, or we can class it as the exponent. So for this, if we had y equals, let's say, we could have absolutely anything, we could have 3 to the power of x, then this is going to be classed as an exponential function because one of our variables, either y or x, is a power. So now let's have a look at the graphs of an exponential. Now what we can see on the diagram is y equals 2 to the power x and y equals 10 to the power of x. Now the key thing and the key property about these exponential graphs is that when you have got a graph with the equation of y equals something to the power of x, then it's always going to cross the y-axis at 0, 1, so at this point here. Now that makes perfect sense, and the reason for that is because anything to the power of 0, so it crosses the y-axis when x equals 0. Now when x equals 0, well, 10 to the power of 0 is 1, so it crosses there. 2 to the power of 0 is 1, so again it crosses at the same point. Now each graph has a different gradient at this particular point, and the value of the gradient depends on a. Now if what you will notice is when you start recognizing with these graphs, that if I then just get rid of this, so as the base increases, so as the base number increases, in other words a, the closer the curve is to the y-axis when x is greater than 0, and the closer it is to the x-axis when x is less than 0. So in other words, if I wanted to plot y equals 12 to the power of x, now I've already drawn 10 to the power of x, so that means 12 is going to be even closer to the y-axis. It's still going to cross the y-axis at 0, 1, and that it's actually going to go further below that blue line. Now the key thing to remember is that these lines never cross the x-axis unless you are looking at graph transformation where you're taking something away from the function. So this line here, let me just write that as y equals 12 to the power of x, and if I was to then plot, let's say y equals a number that's smaller than 2, so let's go for y equals 1.5 to the power of x, well that's going to be below that line, and when it goes through 0, 1, it'll actually be above that red line, so it should look something that looks like this. Now the key thing to remember is that if I then wanted to plot what y equals 1 to the power of x, well that there is just going to be a straight horizontal line through that point. So this point here is y equals 1 to the power of x, and that should be a straight line. So any number between that will be a curve. So anything where the base number is greater than 1 will look like this curve that looks like that. And the bigger the base number, the harder the gradient's going to be, the higher the gradient's going to be, I should say. Now if I then let's say 0.5 to the power of x, well that's not going to go below the line. Instead what's going to happen there is that that's going to be a reflection of y equals 2 to the power of x, and I can write that half as 1/2 on the y-axis. So what will happen is if the red line is y equals 2 to the power x, then if I reflect that, so it looks like this, that line there would be y equals 1/2 x. So it's kind of when you've got a base number that's less than 1 or between 1 and 0, then it's basically going to come in from the opposite angle and it will therefore be reflected. So it's like the reciprocal graph. Now a question that comes up is what types of questions could you are likely to face related to exponentials in your GCSE exam? Well, the types of questions that could pop up are for you to recognise what an exponential graph looks like. So looking out for that y-intercept of 0, 1. And so there'll be an example of multiple choice questions where you're given a graph and you need to match up the equation, or you're given an equation and you need to match up which graph it refers to. Another type of question that can come up is sketching or plotting an exponential graph. So this is either where they give you an exponential equation and you need to then plot another one, so whether it's above that line or below that line, or even a reflection of that line, or you're given a table of values to then substitute the numbers into the table of values, plot the coordinates, and then join the points up with a smooth curve. Another type of question could come up is substituting values into an exponential function or equation, and this type of question kind of relates to compound interest or half-life, which is looking at where you're looking at repeated decreases of percentages. And the last type of question that could come up is where you're asked to find values from an exponential function, so either looking at the variables, and this is incorporating topics such as simultaneous equations and trial and error. So now let's have a look at some past exam questions related to exponential functions. Now you can gain a copy of these questions simply by clicking on the link in the description. You can either have a go at these questions as we go through the answers, or you can simply pause the video, have an attempt at them and see how much of the video it's made sense, and then unpause to see whether you get the questions correct. So let's get started on these questions. Let me just zoom in so it's easy for you to see on the screen. So looking at this first question, it says that the population of butterflies in a park is 4,200. Assume that the population increases by 12% each day. Show that after 20 days the population would be greater than 40,000. Now this question is an exponential question, but it can also be related to compound interest because it's increasing by a fixed percentage over a period of time. So here we've got our original amount, which is 4,200. Now when we're increasing by 12%, we started with 100%, we're adding 12%, so that's going to be 112. That as a decimal or a decimal multiplier is 1.12, and then we've got the formula of D, which is the number of days. So now all I need to do is substitute in this particular question that D equals 20. So then I've got 4,200 multiplied by 1.12 to the power of 20, and if I reach for my calculator, try and work that out, so 4,200 times 1.12 to the power of 20, and that gives me an answer of 40514.43099, which is greater than 40,000. The next question then says that in fact the population increases by 13% each day for 19 days, then decreases 8% for 1 day. After 20 days, is the actual population greater than 40,000? Now with these types of questions, I personally would show you working out and then tick whether it's yes or no. So for this, let's have a look at this line here. Well, for that, we're starting with 4,200, and here we're going to increase by 13% this time, and this is for 19 days, so we're going to put 19. I'm going to press equals there. Then with that, what we're then going to do is it then decreases 8% for 1 day. So then whatever that answer is, I'm then going to multiply that by 0.92, and that's to the power of 1. And then all I then need to do is type that into my calculator and see what I get. So 4,200 multiplied by 1.13 to the power of 19, and that equals 42829.17 0.576. I then multiply that answer by 0.92 to the power of 1, or just 0.92, and it gives me an answer of 39402.8417. So has the population is the population greater than 40,000? Well, the answer is going to be no. Moving on to question 2, it says the equation of the curve is y equals 16 to the power of x. Let me just write that a little bit clearer. And the question says circle the point that lies on the curve. So for this, what we need to do is substitute the x ordinate and see if it equals the y ordinate. So here, when x equals 2, I get 16 squared, and 16 squared is not equal to 32, so it's definitely not that one. Then when x equals 32, so we get 16 to the power of 32, that's definitely not going to equal 2, so we can scrap that answer. Then for this one, when x equals 2, we get 16 squared. Is 16 squared 256? Yes, it is. So that there is my correct answer. It then says that a different point on the curve has a y ordinate of 1/16. Work out the x ordinate. So what we've got is we've got y equals 16 to the power of x. Now for this, we know that y equals a 16th, and this then becomes an indices question. So how can I then turn this into the reciprocal of 16? Well, x needs to equal -1. So I either write x equals -1 or just -1. Moving on to question 3, I'll just zoom out a little bit on this one. It says that Leo wants to draw the graph of y equals 2 to the power of x for the values of x from 0 to 4. Here is his graph, and the question is asking us to make one criticism. Now, often with these types of questions, one of the criticisms is usually going to be that he's either messed up the curve or that it's just the wrong shape. The shape does look fine. It does cross at 0, 1, so that's not the mistake. So all I then need to do is just check these coordinates. So 2 to the power of 1, so let me just write that. 2 to the power of 1 is 2, so that's correct. 2 to the power of 2 is 4, so that's correct. 2 to the power of 3 is 8, so that's correct. And 2 to the power of 4 is 16, not 15. So the correct answer we should, or one criticism we should write, is the last point is plotted incorrectly, and they've plotted, so Leo has, you could say Leo's plotted the last point wrong. And often with these questions, sometimes it's worth saying what it should be. So he has plotted 4:15 instead of 4:16. So anything along those lines would have been absolutely fine. Then moving on to question 4, it says here is a sketch of, let me just get that back on the screen. So here's a sketch of 2 to the power of x on the axes above. Sketch the curve y equals 3 to the power of x. Now we know that it's definitely going to go through 0, 1. So again, if you're not sure, all we need to do here is just write down the equation, so 3 to the power of x, and then just trying to pick out some points. Now here we said that as the base number increases, the line's going to get closer to the y-axis, so it's going to look something like that. And the key thing to remember is that the line doesn't cross the x-axis. It's below the original line. So it's below y equals 2 to the power x, and this is closer to the y-axis after x is greater than 0. So anything along those lines would have been absolutely fine. Now moving on to question 5, it says draw the graph of y equals 0.8 to the power of x for the values of x from 0 to 6. Now this can appear on a calculator paper, so obviously we can use our calculator. Now when we've got table of values, you can just substitute the numbers in. So if I just label this as 1, 2, 3, 4, 5, 6, 7. So for 1 we're doing 0.8 to the power of 0. For 2 it's 0.8 to the power of 1. For 3 it's 0.8 to the power 2. For 4 0.8 cubed, 0.8 to the power of 4, 0.8 to the power of 5, and 0.8 to the power of 6. And we could just simply type that into our calculator. And how do I do that? Well, you should have a button on your calculator that's got a little X with a little box, and then we just press the number, so 0.8, then press that button and then enter whatever the value of x is going to be. So it would be 0, 1, 2, 3, 4, 5, 6. Alternately, one thing you can do is to use the table of function value on your calculator. Now if you're not sure how to do that, if you just get your calculator, then press mode setup, and you should have a function that says table, which here is number 7, and then f of x comes up. So if I type in 0.8 and then press this power button, and then here I'm going to write the value of x, so I press alpha and then close bracket, so I get like that, press equals, g of x may come up, so we could just bypass that because we only work with one equation. Now my starting value is 0 and my end value is 6, and if I press equals, step is going up in 1, so that's fine. And there you can see on your f of x column it tells you the values you need to substitute in. So looking at the calculator, let me just put it on the side there. So when x equals 0 it's going to be 1, then it's going to be 0.8, then 0.64, and then if I scroll down on the calculator, so the next value is 0.512, so 0.512, then I'll just read off because it's going to slowly take up. So then we've got 0.4096, and then my last two values are 0.3276 and 0.2621. So then all I've got to do is just plot these values as best that I can. So 0, 1 is here, then 0.8, which is there, then 0.64, which is there, 0.3, 0.512, which is going to be pretty much there, 4, 0.4096, it's there, and for 5 it's 0.32, so that's going to be about there, and 6, 0.26, which is about there. So all I then need to do is just join those points up as best that I can. So again, mine's going to be a very bit sketchy, and generally speaking it should go through all your points, and just make sure that your line does go through those points. You can see there that I missed out a few, so let me try that again. And it should look something like that. As long as it goes through the points, then you should be absolutely fine. Obviously that one there is a bit suspect. Now moving on to question 6, it says the point 3/1/64 lies on the curve of y equals k to the power of x, where k is a constant, so k is just going to be a number that we don't know yet. And the question is asking us to show that the point half lies on the circle. Now for this particular question, the first thing we need to do is to find k. So using the information, we know that when x equals 3, that y equals 1/64. So here we've got y equals k to the power of x, so then I've got 1/64 equals something cubed. Now to find out what k is, to get k by itself, we need to do the opposite of cubing, which is cube root. So if I do the cube root of 1/64 and I type that into my calculator, so the cube root of 1/64, I get an answer of k equals 1/4. So what the formula of the line is going to be, it's going to be y equals 1/4 to the power of x. So then what I then need to do is then substitute. So when x equals a half, so then I get y equals a quarter to the power of a half, that, and type that into my calculator. Y equals a half, so therefore a half lies on the line. Then moving on to question 7, it says Nick sketches the graph of y equals 0.5 to the power of x, where x is greater or equal to 0. Make one criticism of his sketch. So the key criticism here is that the only point I know, which is this point here, so let's check that this point is 0.5, so it's going to be 0 to the power, or 0 to 0.5, so that's the point there. Now that point there is going to be wrong, so it crosses the y-axis at the wrong point, and so he's crosses at 0, 0.5 instead, and what it should be is 0, 1. So any of those two statements would have been absolutely fine for the 1 mark. Then moving on to question 8, it says y equals p times q to the power of x minus 1, where p and q are numbers. When y equals 10, when x equals 1, and y equals 0.3125 when x equals 6. Work out the value of y when x equals 3. So what we're going to do is we're going to substitute these numbers first to find out what p and q are. And this type of question is very similar to like direct and indirect proportion. So substituting these numbers in, I get 10 equals p times q, and it's going to be to the power of 1 minus 1, which is 0. So it's 10 times p times q, or 10 equals, not times. So 10 equals p times q to the power of 0. Now anything to the power of 0 is just 1. So that's 10 equals p times 1. So p equals 10. Then using the second bit of information we know, so here we've got y equals 0.3125 and x equals 6. So substituting those numbers into this, knowing that p equals 10, so we've got y equals 10 times q, which we don't know, and it's going to be to the power of 6 take away 1. Now y is 0.3125, so I can substitute that numbers in, and I've got q to the power of 5. So then simplifying this, try and find out what q is. Well, I'm going to divide by 10. So I get 0.03125, and that equals q to the power of 5. Now how do I get to the power of 5? Well, I fifth root 0.3125, and that equals q. Now remember, that's not 5 root 0.03125, it's the fifth root. So if I get my calculator back again and just have that on the screen, so if I just press mode and then 1 to reset it. Now here, if I press the button, there should be a root function, so it's this one here. So if I shift and this, I get to choose what root I want, which is 5, and the number inside my surd is going to be 0.03125. Press equals, and it tells me that q equals 0.5. So then what the formula then looks like, it looks like y equals 10 times 0.5, and then here is my formula. So now if I substitute this bit of information into it, I get y equals 10 times 0.5, and it's 3 to the power of 3 take away 1, which is 2, so it's y equals 10 times 0.5 squared. And if I type that into my calculator, which I'm going to do right now, I get an answer of 2.5. Then moving on to question 9, it says the value of a car, which is in V pounds after t years, is modelled by the equation, and here we've got our formula. So the question is asking, it says the value of the car when it's new is 22,000. The value of the car after 2 years is £14,080. The question is asking us to work out the value of A and K. So looking at this bit of information here, we know that if it's brand new, then T is going to equal 0 and V equals £22,000. So let's just write that down. So we've got £22,000 equals A times K to the power of minus 0. Now anything to the power of 0 is just 1, so we get 22,000 equals A. So that's one of the values found. Then using the second bit of information, we know that the value is £14,080, so 14,080 equals A, which we now know is 22,000, multiplied by K, which we don't know, and T is 2. So in this particular bit, T equals 2 and V equals 14,080. So then looking at this, let's just solve this out. So we get 14080 divided by 22000 equals K to the power of minus 2. Now that, what does that equal? Well, 14080 over 22000 equals 16 over 25, which as a decimal is 0.64 equals, now anything to the power of, now if I just translate this to knowing what it means, well that means 1 over K squared. So then from this, what we then know is we can then write 0.64 over 1 equals 1 over K squared. So doing a bit of cross multiplying, we get 0.64 K squared equals 1 times 1, which is 1. So K squared equals 1 over 0.64, and if we square root that, so square root of 1 over 0.64, we get an answer of 5 over 4, which is 1.25. So A equals 22,000 and K equals 1.25. Then moving on to question 10, it says the number of bacteria N after T hours of an experiment is given by, and we've got this formula here. Now if it's not come out correctly, basically the formula is N equals A times 2 to the power of T divided by 4. Now this is where we're looking at half-life and different formulas for this. So it says at the start of the experiment there are 250 bacteria, show that A equals 250. So at the start, which basically means when T equals 0. So if I substitute T equals 0 into this, we get N, which is, N equals 250. So 250 equals A, I don't know why I've put a times there, I always do that, equals A times 2 to the 0 over 4. Now anything over, that's just going to equal 0. So that then is just 0. Anything to the power of 0 is 1. So we get 250 equals A, which is basically what they wanted me to show. It then says, how long is it before the number of bacteria doubles? Well, for it to double, let's have a look. So we're looking for when N is over 500. So all we then got to do is just guess numbers in. So we've got the formula of N equals 250 times 2 to the power of T over 4. So when T equals 1, so let me just substitute that in. So when T equals 1, let's get the calculator back, we do 250 multiplied by 2 to the power of, and it's going to be a quarter, so it's going to be 0.25. Press equals, and you can see there that gives me, it doesn't give me any number near 500. So what I'm going to do is I go back and I just change that power to something else. So I can actually write it like this. So let's now try 2. So for 1 it's less than 500. So when T equals 2, let's try that. So 2 over 4 and that gives me 353, so that's still less than 500. Let's try t equals 3. So let's get the calculator back up and just change that to a 3. Nope. So we try 4, so that's 420. So let's try t equals 4. And that gives me 500, so that does equal 500, so it's going to be after 4 hours. It then says Megan works out that there will be more than 1 million bacteria after 2 days. Is she correct? Well, after 2 days, if t is in hours, that's going to be 48 hours. So in other words, when t equals 48. So let's try type that in. So we've got 250 times 2, and then we're going to have 48 divided by 4 as the power. And so let's get the calculator back up. So we've got 250 multiplied by 2 to the power of 48 over 4. Press equals, and you can see there that have we got over 1 million? We have, yeah. So that equals 0124 with 3 zeros. And so is she correct? The answer is yes. Then moving on to our last example question, it says circle the possible equation of the graph shown below. Now this is an exponential graph because it actually doesn't cross the y-axis, and so this is what we call a reciprocal graph, which is the second option. It then says this graph of y equals 2 to the power x, write down the coordinates of a. Where does it cross the y-axis? Well, we should know that by now, and that's going to be at 0, 1. In other words, when x equals 0, so we've got y equals 2 to the power of 0, so y equals 1, which gives us this coordinate.